students, my name is Hitesh Jindal, and in this lecture today, we'll be talking about the introduction to electrostatics, right? So let us start. Let me share you a presentation regarding that. So as you can see, we'll be discussing about first lecture. This is the first lecture of electrostatics, right? So what do we mean by electrostatics in the first place? So as you can see, here we have two words, right? We have electro, right? And one is statics. So what do we mean by electro? So electro, what what word comes into our mind when we hear this thing electro? Electricity, right? So we have heard this word known as electricity, right? Now electricity is made up of what? What is connected with electricity? That is charges, right? So we know from our previous classes that we have charges in the form of electrons, right? We have heard about protons, right? We know that electron has negative charge, proton has positive charge, right? So that we were discussing. But the point here is that in this electrostatics, this electro connotes what? Electro connotes the charges or the electricity. What do you mean by statics? Statics means that at rest, right? So in our earlier classes, we discussed about current electricity, current electricity, right? Here we will be discussing about static electricity. So what do we understand as a difference between the two is that in current electricity we discuss about the flow of charges, right? Herein the charges are flowing, and that flow is making the current, which is saying that electric current is flowing in this wire. But what happens in this case? Charges are not flowing, charges are at rest, right? So have we ever experienced this thing, charges at rest? So have you ever experienced that when you touch the knob or the handle of a gate, right? And you feel a current, something, a current is you feel that you must have experienced, or with your woolen clothes, right? With your woolen clothes, sometimes when you touch them or you touch another person's woolen clothes, so you feel that current passing through your body. So did you ever experience it? So you might have experienced all these things, or the most this you must have experienced, that you must have done this activity, that when we rub a scale or a comb, right, with our hair, right, with our head, when we rub it, and when we try to bring it closer to some bits of some, right? For example, I have this scale, right? I have this scale and it is rubbed, right? A rubbed scale, and I have some bits of paper, very small bits of paper, right? These are the bits of paper, right? So you see, when I bring it closer to them, when I bring this scale closer to them, what happens? These bits of paper get these bits of paper get attracted to this scale or this comb, right? So why that happens? So that will be discussing in this lecture, that what is that static electricity, right? How it affects the world around us, right? So as you can see, what happens in here, that when we rub this scale, some charges, right? Those charges are, we have positive or negative, only these kinds of charges we have. And that also will be discussing that who gave that name to the charges, right? Why only that positive or negative, right? Why that, how that name was given and who gave that name? So we have negative charges, right, which electrons carry, and we have positive charges which protons carry, right? So we have two types of charges the scale might be having. It depends upon from which it is rubbed, right? So this scale might be having some charges. Let's say this scale might be having negative charges, right? But these charges are flowing. No, these charges are not flowing. These charges are at rest. They are just, you can say, resting on this scale. And when this bits of paper, when the scale comes close to these bits of paper, it attracts them, right? So that also will be looking at that how this attraction takes place, right? So we need to keep in mind that in this chapter electrostatics, we'll be talking about the effects of charges at rest, right? So let us start. So in this lecture today, we'll be discussing about the concept of electric charge, right? What is that electric charge? As I have told you that we have two types of electric charges. We have positive charge, we have negative charge, right? So, so can you like tell me the name of the person who gave that name to the charges, that we have positive charges, we have negative charges? Yes, that we know that we have two types of charges. Charges are of two types. So one is positive, one is negative. Who gave that name? So that person was Benjamin Franklin. Yes, Benjamin Franklin gave that name to the two types of charges, that one is called as positive and one is called as negative, right? All right. So what do we mean by that electric charge, right? Electric charge is the property, right? Property of matter due to which that electric effects take place, right? So that will be doing. Then the most important aspect of this lecture that we'll be discussing, and the questions in competitive exams and in school examinations come, are this charging of a body. So we'll be discussing about the various methods of charging of a body. So we have various methods, and most importantly, we have three methods of charging a body, right? Three methods of charging a body. So that we'll be discussing. Then we'll be discussing the properties of electric charge, right? So what are the various properties of electric charge? So these are the properties that we'll be discussing. First is that the quantization of charge. Charge is quantized. What do we mean by that? Right? We'll be discussing this expression Q is equal to NE. So what is N here? What is E here? What is Q here? That we'll be discussing. Then we'll be discussing the second, conservation of charge, that charge remains conserved. This you might have been learning from your previous classes also, right? That charge can neither be created nor be destroyed, right? It can only be transferred from one body to another. That will be looking at. And then thirdly, we'll be discussing about the third property, that is additivity of charge, how charges get added, right? And fourth is this property, right? Quite a simple one, that charge is invariant, that when charge moves, its value does not change. So all these properties. So the most important topics that we'll be discussing in this chapter is, in this lecture, is that charging of a body, the methods of charging of a body, and the properties of electric charge, right? So this is our lecture one of electrostatics, right? So as you can see here, right? As you can see here, let us discuss about electric charge. Right? So what is electric charge? Right. So that we have understood what is electrostatics. So that definition is also important. Electrostatics is the field of study in which, right, what is electrostatics, that I'll be writing here. But electrostatics is what? It is a field of study, field of study, or what? Study of forces, study of fields, right? And potentials. So in our 11th grade, we learnt about this concept of field in the form of gravitational field. So now here we'll be looking at electrostatic field, right? In our gravitation chapter of 11th, we have studied about the gravitational potential. So here we will be studying about the electrostatic potential. So electrostatics is the field of study of forces, fields, and potential, right, arising due to charges, arising due to charges at rest. Right. So this is important. This is the concept of electrostatics that we'll be studying about. We'll be studying in this chapter the various forces, right? What is various, right? What is electrostatic field of various distribution of charges and the potential, right? So that's all about electrostatics, right? Now, where this word electricity came from, can you tell that electric charge? So electric charge, we know that we have two types of electric charges, positive and negative, and I have told you that the name of this positive, that one is known as positive, one is known as negative, is given by Benjamin Franklin, right? And from where do these charges appear, right? So we have atoms, right? Matter is made up of atoms, and every atom has nucleus in which we have protons, that is the positive charge, and we have electrons revolving around the nucleus, which carry negative charge, right? So we have, so what we have, so there's a body, we have, for example, there's a body, and we have various atoms in here, right? These are various atoms having what? Having protons and electrons, right? So every atom is electrically neutral, right? That we know, that every atom is electrically neutral as they have the number of protons as many number of electrons an atom is having, right? So how is that body become charged? So is this body charged? So we'll say no, it is neutral. Why? Because the atoms in this body are electrically neutral. Now what happens? Let's say I'll take, right. So for example, let's say I'll take one electron from here, right? One electron I have taken from here, right? I have taken two electrons from here. I have taken, for example, let's say three electrons from here, or like that. I have taken one more electron from here, right? So this body loses some electrons. How many electrons this body loses now? This body has lost, right? One, two, six, seven. There's seven electrons this body has lost, right? Loss of seven electrons. So now, does this body becomes charged or not? Does this body become charged? Yes, now this body has become charged because now these seven electrons, right? These seven electrons were balancing the positive charges of the seven protons. Now those seven electrons we have taken from this body, right? Now those seven protons, those seven positive charges of the protons will remain unbalanced, right? So this body will become what? This body will become positively charged. This body will become positively charged. We can also add electrons to this body. If I would have added electrons to this body would have become negatively charged, right? So there should be unbalance, right, in the number of electrons and number of protons of all the total atoms of a body, right? If that unbalance has arisen, then the body becomes charged. So that is all about electric charge, right? So what we have understood from this point is that we can charge a body by what? Very important point, that a body, that is our next topic of discussion, that how to charge a body. But that we know that a body can be charged by either gain or loss of electrons. So electrons play a very important role in electricity, right? Because electrons only we can add or we can take away from a body. We cannot take away, we cannot add protons to a body because protons are bounded in nucleus, right? Electrons are relatively free, so we can take away or we can add them to a body. So electrons are very important subatomic particles for this static electricity also and current electricity also. We have already seen in our current electricity from previous classes that it is the electrons only that flow in a wire that constitute electric current we are getting at our homes, right? All right. So this also is a very important point. I want you to know that. What about this electrons, right? From this electrons word only this electricity has come, right? So there was in 600 BC, right? A very long time back, 600 BC, there was Thales of Miletus, right? In Greece, we have, right? So what he did some experiment, right? What he did some experiment. Was Thales of Miletus. You need not remember the name, right? Just you can wonder about that how long back we have got this, we have cracked this thing. So there was this stone known as amber, right? Amber is a stone, is a kind of stone, right? So when this amber is rubbed, right, this amber is rubbed with something with a cloth, let's say. So this rubbed amber, when it is brought closer, right, that is brought closer to some light objects, or we can say, let's say, when this amber is brought closer to some bits of paper, right, bits of, let's say, paper, some light objects. So what this amber is doing, it is attracting them, right? It is attracting them, attracting the bits of paper. That means that the amber has become charged, right? That we have seen from our gravitation chapter also, that this paper and this amber is not having that much mass that they attract each other due to the gravitational force. So there must be some charges involved in this force of attraction, right? So from here, this comes this concept of electrostatics. We have uh, started to understand this concept of electrostatics, right? And this amber is known by another name, right? Electron, right? It is the name of the amber, electron, right? And from here only we get this name electricity. So an interesting fact that you should be knowing, that from this word amber, this electricity is coming, right? And amber was the first time that this is documented, that this amber, after being rubbed by something, after being rubbed, is attracting light objects, right? All right. So let us move ahead, right? And let's discuss our first method of charging, right? So now we'll be moving on to methods, methods of charging, right? So as you can see here, so I have told you this is one of the methods as we have done with amber. So it is rubbed with something. And when we rub two bodies together, right? So the surfaces are being rubbed together. And in between these surfaces, there is a force of friction, right? So our first method of charging is charging by friction. Charging by friction, right? So what can we do here? So you see here we have plastic rod, right? We have a plastic rod and we have a silk cloth. So I can rub a plastic rod with a silk cloth, right? And in this rubbing, some heat is generated. What happens when we rub something, due to friction between the surfaces, heat is generated. And due to that heat generation, right? Due to that heat generation, what happens? That heat is taken by the electrons, right? So the electrons of one of the bodies get that heat and they become free and they are transferred to another body. Like we are seeing, this is happening in this case. right? In this case, as it is happening, you can see that when it is being rubbed with the plastic rod, this is silk cloth. The silk cloth is getting the electrons, right? So this silk cloth is becoming negatively charged. And from where these electrons are coming? These electrons are coming from the plastic rod, right? So this silk cloth is becoming what? The silk cloth is becoming negatively charged, right? And this plastic rod is becoming what? Positively charged. So in this charge, so both the bodies become charged. Silk cloth has become charged. Plastic rod has become charged by the method of friction, right? So that depends that why this plastic rod has not become negatively charged, right? So that depends upon the material from which it is being rubbed, right? For example, if this plastic rod, if I'll rub this plastic rod with cat's fur, right? Cat's fur, right? We have fur on the cat, right? So if the plastic rod is rubbed with the cat's fur, then what happens? This plastic rod becomes negatively charged, right? And this cat's fur become positively charged. So also in this charging by friction, what are the materials of the two bodies involved, right? That will decide. So the that will decide that which body will become positively charged, which body will become negatively charged, right? So, but the point to understand here is that we can charge bodies by rubbing, by friction. And why the bodies become charged? Because friction, when we rub, that generates heat, and due to heat, that electrons get energy, and electrons get transferred from one body to another, right? Also, very important, uh, that this charging by friction method is also known as, by this name, known as, write it, is known as triboelectric effect. Triboelectric effect, right? Tribo means friction. Tribo means friction. So this electric effect coming due to friction, right? So that is known as triboelectric effect, and that happens in the case of charging the body by rubbing or by the method of friction. Got it? So we can have many other materials. For example, let me give you one example also. One more example, that if we have a glass rod, right, instead of a plastic or glass rod, and we have, let's say, silk cloth. So now when we rub them together, what will happen? When they're rubbed, right? When they're rubbed, what will happen? When they are rubbed, this glass rod will become positively charged. Obviously, rubbing will get both the bodies charged, but who will become positively charged, who will become negatively charged, depends upon the types of materials involved. Got it? And this silk cloth will become what? It will become negatively charged in this case, right? So now, if I'll have, let's say, two glass rods, and two glass rods, both are rubbed with silk cloth, different silk cloths, and they are brought together. So we know that both those glass rods are positively charged. So what they'll do? They'll repel each other, right? Now, if I'll bring a glass rod rubbed with silk cloth, and I'll bring it near to a plastic rod rubbed with cat's fur. Now the glass rod is positively charged, plastic rod is negatively charged. So both will attract together, right? All right. So let us move ahead, right, and try to discuss one more method of charging, that is known as a second method, which is charging, right? Charging by conduction. Charging by conduction, right? So what happens in conduction? What we do? We touch two bodies, right? So let's say we have, as you can see from the diagram here, that we have two bodies. One is uncharged, one is charged, right? And let us say these two bodies are identical. Let's say these two bodies are identical. Identical means both have the same material and both have the same radii, right? So now, and let me say that this charged body is having some charge. Let's say this charged body is having 5 coulombs charge, right? That is a very large charge. 5 coulombs charge this charged body is having, and this is an uncharged body. Now this charged body is brought in contact with this uncharged body. So what will happen? By the method of conduction, right? Both are, let's say, metallic bodies, right? Both are metallic bodies, both are metals. So when a charged metal is brought in contact with an uncharged metal, the charges from the charged metal will transfer to the uncharged, and both will, and the uncharged metal gets charged, right? So you can see both will get positively charged. So it is charging by conduction, or also it is known as charging by contact. We have just brought one charged body in contact with an uncharged body, right? And this principle, this method of charging is applied in a very important device that we use for measuring, for detecting the amount of charge on a body, which is known as electroscope. That we'll be discussing, and also I'll be showing you a video regarding this, right? Electroscope, right? So we are just bringing a a charged body in contact with something, so that another body is also becoming charged by the transfer of charges that is happening, right? So if we have identical bodies, so obviously both will get the equal amount of charge. The redistribution of charge is happening. So what is happening here? So here we are having redistribution. This is the keyword. We are having a redistribution of charges, right? All right. So if this is 5 coulomb, so we'll be having what here? We'll be having here half of it, right? We'll be having here 2.5 coulomb. We'll be having here 2.5 coulomb, right? So both will be having equal charges, right? So this is the method of charging by contact or by conduction, right? I can also do one thing. If both are metallic, so let's say this is uncharged and this is charged. So I can also do one thing. I can connect both of them by a conducting wire. So let's say this is a conducting wire. So this way also I can charge the bodies. Then also this will become charged, right? Then also we will be having. So this way also we can charge our body, right? So there here we are not rubbing anything. So one method is rubbing, another method is by conduction or by contact, right? So let us see this very important device here, which is electroscope, right? Electroscope. So as you can see from the diagram, what we are having here is we are having here a glass container, right? We are having here a glass container, right? And you just focus upon this thing. We have this disc here, right? This disc is of metal, right? And what is here? We have gold leaf. This is also known as gold leaf electroscope. So we have two gold leaves, right? Which can move like this, right? So these are gold leaves. Gold is also a metal. So these are all connected with, you see, this is a brass rod is connected from here to this brass disc, right? So from here to here, we have metal, right? Now you can see what we are doing. We have this positively charged ebonite rod. Ebonite is a material, right? So we have made it positively charged, let's say by rubbing, right? Or any other way we can charge this rod. So it is positively charged, or it has some positive charge. Now, when this positively charged rod is brought in contact with this brass disc, what will happen? Just brought in contact with it. So this brass disc will have some of the charges of this rod, right? The transfer of charges will take place. Transfer of charges will take place, right? So now this transfer takes place. Now this positive charges come to here, and they are connected to these gold leaves. So these positive charges will go here also by conduction. So these two gold leaves will get positive charges, and we know that both the gold leaves, as they are having positive charges, so like charges repel. So these charges on the gold leaves will make them repel, and there is some angle that is coming, right? You can see here we are having some angle theta. This is the angle of deflection, we can say, right? This is the angle of deflection we are having here, right? So now what it does, what this electroscope does, now this theta, the value of this theta, the value of this theta is proportional to what? This value of this theta is proportional to the amount of charge on the ebonite rod, right? More the charge this rod is having, more will be the transfer of positive charges and more will be the deviation of the gold leaves, right? So this electroscope is a device which is used to detect the amount of charge. Now let's say if I have some material, and also it detects that if the body is charged or not. So now let's say I have some material, I have some rod which is uncharged, and if I'll bring that uncharged rod and I'll bring it in contact with this brass disc, will there be some deviation? There will be no deviation. No deviation will be there because that body is not charged. So no charge transfer will take place. No charges will reach these gold leaves for the deflection to take place, for the repulsion to take place, right? So it tells you that if a body is charged or not, that you can test from this device. And also, as per the deflection of the gold leaves, as per the angle of this angle of the separation between these gold leaves, we can tell that if the amount of charge that the charged body is having is more or less, right? So let us just have a look at this video, right? Let's have a look at this video uh, to understand more about this electroscope. You can see here that this is this electroscope we are having, right? It is a very sophisticated one. In lab we have it here. So these are the two leaves we are having, right? You can see. So these are the two leaves we are having in here, right? So now, and this is the metal knob, and this is the knob we have. Now, when it is touched, you see, when this, you see here, so now it is touched. Now it will be touched. You see, it will be touched, nothing. So body is uncharged, right? Now again it is touched. Now the body is charged, and you see the deflection has happened, right? So more the amount of charge on the body, more will be the deflection. Got it? You see, you see it here, right? So that's how this thing is happening, right? All right. So let us move further to our next method of charging. The last method of charging that we'll be discussing is you can see here we have very, very important from the examination point of view, right? So third method is known as charging by induction, right? We have charging by induction. So here, neither we are rubbing anything, neither we are bringing in contact. We are just bringing it near to something. As you can see, just inducing, just by bringing it closer, not touching, we are charging a body. How we can do that? So let's say initially we had this metal ball, right? This metal ball had nothing. It was like this, right? These are the insulation stands so that charge can not transfer to the earth. Right? So this is a metal body we have, right? A metal sphere we have, let's say. So charges were like what? Equally distributed. Plus, right? You can see here plus, minus, minus, plus, plus, minus, equally distributed, right? Uniformly distributed. So this is electrically neutral, obviously. So now I have brought this positively charged rod near to it. I'm not touching it. So what will happen? This positive charge on this rod will will make the negative charges in this metal come closer to it, right? So there'll be redistribution inside the metal ball only. Even now it is electrically neutral, right? Because the amount of negative charge is equal to the amount of positive charge. But there has been some redistribution. Positive charges get repelled from this rod and negative charges get attracted, right? Right? We have not done anything. Uh, we have not touched anything, right? Now what we do? Now what we do? We put earthing here, right? This is earthing or grounding, also known as grounding. So what happens by earthing? The positive charges which were here, no, these positive charges go to the earth. So whatever charge we have on a body, whatever type of charge, positive or negative, and when we do earthing, all the charge get to the earth, right? So all the charges get towards the earth, right? So this part now is not having any positive charge, right? Now you see, now is it electrically neutral? No, now it is not electrically neutral. Now it is negatively charged. But these negative charges remain on the side of the rod because now the rod is here only, right? So they are attracted towards the rod. Now what we do? Now we remove the rod. Now what we do in here? Remove the rod. Remove the earthing, right? We have nothing here. Now remove the rod slowly. So now you see these negative charges get distributed on this metal sphere. So this metal sphere has become what? This metal sphere has become negatively charged. So we have not touched anything. We have not rubbed anything. Just by bringing one charged body closer to an uncharged body. This was uncharged, right? This was uncharged initially. This was uncharged. So by bringing it closer, we are inducing charges in a body, right? Yes, we have used earthing here, but by just bringing closer, by not even touching or rubbing, we can charge a body. So this is the third method of charging. We have charging by induction, right? Here we can charge two bodies at the same time, right? That we can do. So this is also by the method of induction. So these two scenarios come in our examinations. That's why I'm discussing them here, right? So you can see we have two metal bodies. Let's say this is A and this is B, and they are in contact with each other. And now again, we have brought a charged rod near to them. Now what will happen? Now, obviously, both these bodies are electrically neutral. So what will happen? So all the negative charges are attracted towards this. So negative charges come here, positive charges will be repelled, so they'll come here. Now what we do? Now we have just separate them, a little separation, not much, a little separation, so that negative charges are here only, positive charges are here only. Now we remove the rod. Now we remove the rod. So we do not even need earthing here, and we separate them more. So now you see the electrons. So this has become negatively charged. A has become negatively charged. And this has become this B. This was B, this was A, and B has become positively charged. Just by bringing a charged body near to them. So this is method of charging by induction, right? Very important. So we have learned three methods of charging, right? One is by friction, also known as triboelectricity, by rubbing. Second, by contact or by conduction. Third, by induction, right? All right. All right. So in between this, let me just then we'll be coming to the properties of charge. So the very small discussion that would be. Meanwhile, I'll be discussing with you. I'll be showing you a simulation, right? So next are here is properties, right? Properties of electric charge, right? So that we'll be discussing, right? Before that, let me just show you a simulation to understand more about the static electricity. So as you can see here that we have this a simulation. We have a sweater here, right? We have a woolen cloth here, right? And you can see all and this woolen cloth, this woolen sweater is what? This is electrically neutral, right? Equal amount of positive and negative charges are there on the cloth, right? On the sweater. All right. So we have three things here. This sweater, electrically neutral. This balloon we have, obviously electrically neutral, right? And we have a wall here, right? We can remove this wall. We can remove this wall for now, right? We can add this wall. This wall is also electrically neutral. Let's remove this for now, right? All right. Now, if I'll bring this balloon, right, closer to this, right? If I'll bring this balloon closer to this and rub it with it, right? Rub it with it. So you see what will happen. I'm bringing this balloon closer to this and I'm rubbing it here. So you see here, I'm rubbing it. So as I'm rubbing it, you see the balloon is getting the electrons from the sweater, right? Now this balloon has become what? This balloon has become negatively charged. You can see the blues. And this sweater has become positively charged because it has excess in it, and this is excess blues in it, this balloon. The sweater has become positively charged, balloon has become negatively charged. Now, if I leave this balloon near to it, so you see both will attract each other. You see, I'm leaving it. So you see, they're attracting each other. If I'll So why they're attracting each other? Because they have become charged. One has become positively charged, one has become negatively charged, right? And why they have become charged? Due to rubbing. So this effect, this force of attraction which we are seeing, the bodies have become charged is due to what? Static electricity. Charges are not moving. Just by rubbing, they are getting transferred, making the bodies charged and thereby the forces of attraction or repulsion, depending upon the charges are like or unlike. Right. So let us reset this. Now the electrically neutral. Now you see balloon is not getting attracted. Balloon is not getting attracted. Right. So let us do this one more time. And let's have a wall also here. Right? Now, wall also here. So what is the meaning of it? I'll just show you. Now I'm rubbing it with it. Right. You see. So the more I'm rubbing, the more electrons I'm getting. Right. So now I've got more electrons. So more negatively charged I've made it. More rubbing, more charges you'll get. Right. So now you see, yes, it will get attracted and it will get attracted. The attraction, the strength of the attraction is more because now the bodies are have more charge on them, right? Now what happens? Now this wall is electrically neutral. Now if I'll bring this balloon to this wall, just bringing it closer, you see the induction thing, right? Induction thing from here. Now this is charging by rubbing. Now if I'll bring this balloon closer to here, what should we observe? You see, this is negatively charged and this is electrically neutral. So what should have happened? So if I'll bring it closer, if I'll bring it closer to the wall, the negative charges should repel and the positive charges should come closer to the balloon. So if it will happen or not, you see. So you see. Yes, you see, this is I have brought it closer to the wall. The negative charges had gone far away from the balloon, right? And thereby the positive charges are closer to the balloon, right? So this side of the wall, the left side of the wall has become positively charged, the right side of the wall has become negatively charged, right? So obviously this is the attraction. It will be here only because this is positively charged, this part, and negative charges are away from it, right? So this is induction. This attraction that is happening is due to induction, right? You see, I have not even brought in contact with, this is a charged body. This balloon is a charged body now. I am not bringing it in contact. I've just brought it closer, and now it is making the wall polarized, right? The polarization is happening. So one side is become positively charged, another side is become negatively charged. Got it, right? All right. We can also have two balloons in here, right? For example, let's say I'll rub this balloon with this, right? So it is becoming what? It is becoming negatively charged. We got it. Obviously, it will get attracted, and also I'll rub this balloon also, right? So I'll get some of the negative charges here. So you see, both these balloons have becoming what? Both these balloons are becoming negatively charged. So what will happen to them? They'll repel, obviously. You see, they'll repel, they'll repel. You see, right? So this is all the effects I have tried to show from the methods of charging we have to the simulation, right? So the point to be noted here is that there is no flow of current is happening, no flow of charges is happening. Just the charges are getting transferred, making the bodies charged, and thereby these forces are coming into picture that we are observing here in this simulation, right? All right, so let us get back to our presentation and we'll discuss the last part of our lecture, that is the properties of the charge. Right. So you see, so first property that we'll be discussing here is known as you can see here, the image shown is known as additivity, additivity of charges, right? So what do we understand by additivity of charges is that let's say I have this body here, right? You can observe we have a body here, and this body is having q1, q2, q3, qn, right? Many charges this body is having. And let's say we can have some values also. Let's say q1 is something, uh, we can have this value as, let's say this q1 is plus 3 coulomb, let's say a large charge I'm taking. Q2 is having, let's say, minus 2 coulomb, right? Q3 is having, let's say, plus 4 coulomb, right? And similarly qn and all, right? So let's say I have this body, right? So I have this body having q1, having q2, having q3, right? Now if I want to tell the charge on the body, what is the total amount of charge? So what I'll do, I'll add all the charges. So the q net, that is known as q net on the body, right? So if I want to know, if I want to know the q net on the body. So what I'll do? I'll just add these charges Q1, Q2, Q3. And how will I add them? I'll add them with proper signs, right? So Q1 is my plus 3, so I'll write plus 3. Q2 is my minus 2, I'll write minus 2, right? Q3 is my plus 4, so I'll write plus 4. So what is that? This value is coming, you see, 4 minus 2. So it's just 5. So plus 5 coulomb is the charge that this body is having, right? So that's how the charges are added. That's how we can get a net charge on our body, right? So charges are added what? How charges are added algebraically. right? So we can say this is known as algebraic addition of charges. Algebraic addition of charges, just like we add the real numbers, right? So we add the real numbers with proper signs. If it is a positive real number and if it is a negative real number, we put them when we are adding with proper signs, right? So that is the important point here to notice, that when we add charges on a body, we put the values with proper sign, right? So that is the whole point that is there in this property of electric charge, right? That the charges are added algebraically, right? So now let us move on to the next property, very important one, right? That is known as the quantization of charge. Quantization of charge. What does that mean, right? And who talked about it? So there are two names associated with it. You can explore them more. So one is Faraday, right? Faraday, through his experiments on this electrolysis, right? So he discovered this thing, the quantization of charge, and one more personality is involved here, which is known as Millikan, right? Also, we have this experiment, Millikan's experiment, oil drop experiment, right? So questions also come from here, oil drop experiment, right? So it comes from our basic understanding of static electricity. So as we see how a body becomes charged, let's say I have this body here, right? I have any body here, any body. So if I want to charge this body, what can I do? Either I'll take away electrons, right? Either the electrons are lost or either the electrons are gained, right? Either there would be a gain of electrons, right? So I cannot take away or I cannot add a fraction of an electron. I cannot take away half electron. I cannot add a quarter electron. That electron must be transferred, the electrons must be transferred in integral multiples. So we can add 2 electrons, we can add 200, we can add 2000 electrons, but we cannot add 2000 point, right? 2000 point, let's say 5. So point 5, that half electron is not possible to be transferred, right? So that is the whole meaning of quantization of charge. So let's say this this body which we are having, right? So this is losing electrons. So let's say it has lost what? It has lost, let's say, 12 electrons. The 12 electrons are lost, right? So if it has lost electrons, what will it become? It will become positively charged, right? It will become positively charged, right? Okay. Now, what is this E? You can see this is E. What is this E? This E is the charge on an electron. So we know that what is the charge on an electron? So charge on an electron is minus E because it is negatively charged. Charge on a proton is plus E, right? And what is that value of E? This is, you can written here, 1.602 into 10 to the power minus 19 coulomb, right? That is the charge on one electron in negative value and in positive value on the proton. So now if 12 electrons are lost from this body, it will become positively charged. And if I want to know how much charge this body has got, so this, let's say this body is A. So what is the charge on this body A? So the charge on this body A will be what? 12 into E, right? Why 12 into E? And plus E or minus E? Plus E, because it has become positively charged, right? So there would be unbalanced 12 protons that remain here, which will contribute to the 12E positive charge. So what I'll do? I'll do 12 into, and the value of E, that is 1.6, we can take into 10 to the power minus 19 coulomb. So this would be the amount of charge that this body is having, right? So that is what is here, that the charge on a body would be in the integral multiples of E, right? N is the integer here, right? Integral multiples. N can have one value, two value, three value, up to infinity, but it would be an integer, right? N would be an integer. because because the body is getting charged to transfer of electrons, and electrons can only be transferred, added, right, can be taken away only in whole, right? We cannot take half of an electron, right? So similarly, if this, let's say this is gaining, for example, 25 electrons this body B is, let's say, gaining. So how much would be the charge on this body? So the charge on this body QB is what? Minus 25E, right? Why minus? Because now we have unbalanced 25 electrons in this body B. That will be minus 25 into 1.6 into 10 to the power minus 19 coulombs. So this would be the amount of charge that this body B is having, right? So that is the meaning of quantization of charge, that charge on a body, charge on a body can be increased or decreased in steps, right? In steps. And what are those steps? Those steps are in steps of E, right? So charge can be increased or decreased in steps of E, right? If you're adding, let's say, one electron, right? So let's say this is a body and you have added one electron, so it has become E. You have added another electron, it has become minus 2E, right? Let's say it has become minus 3E. If you add one more, it will become minus 4E. So you can see, you can add electrons in the hole and the charge can be increased or decreased in the steps of E. So that is the meaning of quantization, right? All right, so let us move further and discuss this property, right? Which is the third property we are having in here, is the conservation of charge. That charge is conserved. Charge remains conserved. Charge can neither be created nor be destroyed, that we know, right? So now you see, let us see this with the example which we have seen, that when a glass rod and a silk cloth, let's say, are wrapped together. So both are becoming charged. So this glass rod is becoming positively charged. You can see the silk cloth is becoming negatively charged. So this positive charge is coming from where? This negative charge is coming from where? Due to transfer of electrons between the two, right? So there's no extra charge being created and there is no charge that is being destroyed, right? There's no charge that is being destroyed in this glass rod to become positively charged. There's no charge that is being created in this silk rod to become negatively charged, right? Only the transfer is taking place, right? So charge remains conserved. How can we understand it better? You can see here that when they were not rubbed, right? Initially, total charge was zero. Glass rod was having zero charge. Silk cloth was having zero charge. Now the rubbing has takes place, right? Now the rubbing has taken place. So after rubbing, glass has become positively charged, silk has become negatively charged. Why? Because there's a transfer of electrons. Got it? So let's say, uh, from glass to silk cloth, the electrons are getting transferred. So let's say, for example, let's take a very creative number, 98, right? For example, let's say 98 electrons got transferred from glass to silk. So how much is the charge that the silk is having? You can see, as we have now know, it is minus 98E. Those 98 electrons are in excess. And what is the charge on this glass rod? It has lost 90 electrons. So 98 protons are in excess. So it would be having plus 9080. Right. So now if I'll add the total charge of the system, that will be plus Q minus Q, or we can say plus 9080 plus minus 9080. What it would be? It would be zero. Right. So charge remains conserved. So it says that the total charge. So it says that the total charge of an isolated system, right? So this system is isolated. That means that there's nothing beyond these two bodies, right? In this space, there's nothing beyond these two bodies. Only these two bodies are there. The transfer is taking place, or the interaction is taking place only between these two bodies. Of an isolated system remains constant. or conserved, right? So this question also is an NCRT, right? This thing, that how can we explain that the conservation principle, that the principle of conservation of charge is valid in the case of charging a body by wrapping or by friction, right? All right. And so you can see I have also put this question here, right? So this can only be explained by this thing only, right? So this is a question from NCRT. We have that when a glass rod is rubbed with a silk cloth, right, charges appear on both, right? A similar phenomenon is observed in many other pairs of bodies. Explain how this observation is consistent with the law of conservation of charge. The answer to this is in a previous slide. Just this only we have discussed here. So you will draw these diagrams also, and you will write the explanation, right? That the total charge of an isolated system remains constant, right? Yes, the bodies get charged by the transfer of charges between those two bodies only, right? So ultimately, the total charge of the system remains constant, remains conserved, right? All right. Now, this is the last topic, last property, that is charge is invariant. Right? Charge is invariant. So what do we mean by that? That means that, let's say this person is a charge, right? Q, and its velocity. This is the velocity of the body. The velocity of the body is zero. So let's say the charge is having some value 6 coulombs, right? So now it starts to move. It is having some velocity. It is having some velocity not equal to zero. So it is moving, right? So the charge would change. Will it become less? Will it become more? No, no. It will not change. So Q will remain 6 coulombs only. So this is the property that charge is invariant. It does not vary on the movement of a charge, right? This is a very simple property, right? So now let us look at some one or two questions, and then we'll conclude the session, right, for our lecture 1 of electrostatics. So as you can see here, we have an object which is a charge of 1 coulomb, right? So we have a charge of 1 coulomb, and this and gains this much electrons. So now the net charge on the object becomes what, right? So already the object is positively charged. You can see here, right? Already the object is positively charged. It has 1 coulomb of charge. Now 5 into 10 to the power 18 electrons are gained. So negative charge it is gaining. So the net charge would become what? 1 coulomb plus the charge due to the electrons. What is the charge due to the gain of the electrons? So I'll write it here. Charge due to gain, due to gain of electrons, right? What it would be? It would be, as we can note here, it would be minus of any, right? So how many electrons have been gained? 5 would be minus, right? Because electrons are, the body is gaining electrons. Minus 5 into 10 to the power 18 is the n. E is what? 1.6 into 10 to the power minus 19 coulomb, right? So you can see here. Right? You can see here what it would be. You can see 10 to the power 18, it will cancel out, right? It will be minus 1 just left. Now 1.6 into 5 is what? It is 8, right? So we'll be having what? Minus, and 10 to the minus 1, minus 0.8 coulomb, right? So minus 0.8 coulomb. Now the body is already having, so you can see the body is already having 1 coulomb of charge, and this minus 0.8 coulomb is coming. What is the net charge? 2 net charge. So the net charge would be what? 1 plus minus 0.8, right? So that would be what? That would be 0.2 coulomb, right? So our answer would be D. Got it? Got it. So now let us discuss this last question. This is a question from NCRT we have, right? So you can see that here that we have a polythene piece rubbed with wool, right? So we have a piece of polythene, one material is this, one material is wool. So they are rubbed. Triboelectricity, right? You remember. All right. Is found to have a negative charge of this. So this polythene piece, right? So this polythene piece is having this much charge. So it is asking us the number of electrons transferred. So you see, so we have a right. So we have a polythene piece, we have a wool, right? So let's say this is polythene piece, polythene, right? And this is we have wool, right? So you can observe here, it is saying that this polythene is having how much charge wool is having? This polythene is having QP, let's say we say it is having minus 3 into 10 to the power minus 7 coulomb of charge, right? So now this is having negative charge. Why this negative charge? How this negative charge has come? Electrons got transferred from wool to the polythene, right? So wool has become what? Wool has become positively charged. Now, if I want to know the number of electrons that got transferred, so how do I calculate it? So the charge is this, right? So what I'll say? So I can do it by this. So this charge appears here. This charge on this polythene must be due to the transfer of gaining of electrons. That would be minus of N. Let's say N is the number of electrons that got transferred. What is this charge? It is minus 3 into 10 to the power minus 7 coulomb, right? N we need to find. And what is E? E is 1.6 into 10 to the power minus 19, right? Coulomb. So both are in coulomb, right? So you see, minus minus get cancelled out. So we'll have N as 3 into 10 to the power minus 7 upon 1.6 into 10 to the power minus 19, right? So if you'll observe from here, so minus 7, and when this minus 19 will go, it will be minus 12, right? So that will go above, right? Now if I'll divide this, right? So if I'll divide this with 30, it will become what? It will become 1 point something 87, right? So it will be 1.87 into 10 to the power, it will be above, so it will become 12. 1.87 10 to the power 12 electrons that got transferred. So you can see for such a small charge, you see it is not even, it is in the form of micro coulomb, right? 10 to the power minus 7 it is, right? So in such a small charge, we are having so many number of electrons, right? So coulomb is a very large amount of charge. If I'll say that a body is having 1 coulomb, it is very large amount of electrons that must have got transferred to attain that charge, right? Okay. So this much charge has got transferred. Now, very interesting question we have in here, that is there a transfer of mass also from wool to polythene? Right? Electrons got transferred. So is there any, yes, charge got transferred, but also mass got transferred. What do you think? Yes, mass got transferred, right? Because electrons have mass, right? However small that may be. So mass of an electron is what? Mass of an electron is something like this, 9.1 into 10 to the power minus 31 kg. Yes, it is a very light, it is a it is subatomic particle, right? So very small mass, but yes, it is having mass. So there is a transfer of mass, right? So these many electrons got transferred from wool to polythene, right? So the mass of these many electrons got transferred, right? So the mass, transfer of mass, that is, so how do we calculate that? Transfer of mass is what? This is mass on one electron, and how many electrons got transferred? This much. So it would be 9.1 into 10 to the power minus 31 into 1.87 into 10 to the power 12 in kgs, right? So what will I do to calculate that? I'll have to multiply this n with the mass of one electron, right? So this thing we can calculate here, and we can calculate the mass. So the question is, we need not calculate the mass, but it is just asking that is there a transfer of mass or not? Yes, we can do this, and also we can calculate the answer. So I'll be asking you the answer to this question, the uh, exact number or how much mass will be transferred in kgs. So we'll calculate and let me know in our next session, right? So thank you for the session today. So let me just summarize what we have done. We have understood most importantly the three methods of charging, right? The three methods of charging we have understood, right? One is charging by friction. Also, I have shown the simulation, right? One is charging by contact or conduction related to the gold leaf electrostatic that we have seen in the video. And then we have charging by induction, right? Then we have seen the important properties of electric charge, right? That charges are additive. We can add them algebraically. Charges are quantized, right? So we can increase or decrease the charge on a body in steps of t, right? Then we have learnt about the charge, the invariance of the charge, that it does not change its value in when it is moving, right? And also we have understood that property of conservation of charge, right? So also we have seen the numericals. So I'll advise you to revise whatever has been learned, and we'll get back to our further understanding of electrostatics, right? So thank you for attending this session.